The following table contains observed frequencies for a sample of 200. Test for independence of the row and column variables using alpha equal 0.05. So in our table we have 3 column variables A, B and C and 2 row variables P and Q, and in the first row of the table we have the values 20, 44 and 50, and in the second row of the table we have the values 30, 26 and 30. Our null and alternative hypotheses are as follows. The null is that the categorical variables are independent, and the alternative is that they're not independent. Here are our observed frequencies. We calculate the expected frequencies by going to the original table, multiplying the row total by the column total, and dividing by the overall total. And we do that for each cell in the table, and we obtain these expected frequencies. Next, to calculate the chi-squared statistic, we take the difference between the observed and expected frequency, square it, divide by the expected frequency, and then sum over the 6 entries in the table. And if we do that, we obtain 7.9 for our test statistic. Next, we need to know the degrees of freedom for the chi-squared distribution that we'll use, and the degrees of freedom is equal to the number of column categories minus 1 times the number of row categories minus 1. And so that comes to 2 in this case. And if we look at the chi-squared table and look along the degrees of freedom 2 row, we find that 2 critical values that lie either side of our test statistic are 7.378, corresponding to a tail area of 0.025, and 9.210, corresponding to a tail area of 0.01. So therefore our p-value, the area to the right of 7.9, will be in between 0.01 and 0.025. Our p-value is therefore less than our significance level alpha 0.05, and so we reject the null in favor of the alternative, and so this means there is evidence that the categorical variables are not independent.